Okay, so in this example, we're going to look at integrals where you have a product of sine and cosine, where at least one of them is raised to an odd power. And the general trick here is to pull out one of the terms here that's raised to the odd power. So let's pull out one cosine. And then take the remainder, so take the remainder of what's left here and put it all in terms of sine. So I already have, because we're leading to setting up a u substitution, where we're going to want to let our u be sine, because then you'll notice we have our du sitting right here. So before we can do a nice substitution, we need to take the rest of this cosine terms and rewrite it in terms of sine. So we're going to use the identity that relate cosine squared and sine squared. And this identity then tells us that we can replace cosine squared with 1 minus sine squared. So we're going to do that here in the integral, which means that this term right here we can replace with 1 minus sine squared. Okay, and now we have ourselves in a good situation to do a u sub, because now notice, if we just let u be sine, then we have the du sitting right here. So if we let u be sine, then du is going to be cosine x dx, which is exactly what we have right here. And I'll be able to replace everything to be in terms of u and du, and then we can just integrate straightforward from there. I.e., in this case, we'd have it like this, and then you would expand out that integrand into powers of u, integrate term by term, and then put everything back in terms of x. So we're going to try this with an example, but I want to also put a caveat. You may not get integrals that come to you in the form of sine and cosine already. You may see them in the form of, say, cosine and tangent, or sine and cotangent, and your best bet is then to rewrite them in terms of sines and cosines and see if one of these substitutions will work. So we'll do that as a second example after trying a basic one like this. Okay, so here's an example that fits that form. So now take a second, put this on pause based on what we showed as the general idea. See if you can work through the setup of what you're going to need for the u substitution with this one. Okay, so first you're going to pull out one of the cosines with the goal of making this become our du, and we're going to rewrite this in terms of sine so that we can use the u substitution. U is going to be sine of x, and then du will be cosine x dx. So remember, cosine to the fourth, that's the same as cosine squared, quantity squared. So I'm going to replace cosine squared with 1 minus sine squared. And then it's all squared here, and then I'm still left with cosine x dx. And then you can see right away that that's going to leave us with u squared times 1 minus u squared quantity squared du. And now to do this, you're just going to FOIL out this middle term here, distribute the u squared through, and then integrate term by term. And then at this point, you're just going to get e to the third. Okay, plus these terms here, and then you're going to switch everything back to be in terms of x at the end. So let me just make some more room. So we'll get this as our final answer. Okay, and now we're going to we'll look at a case where it doesn't come to us as a product of sine and cosine, but after we do some manipulation, our integrand will involve sines and cosines, and you can usually use a similar type of substitution. Okay, so go ahead and put this on pause and see if you can do this one yourself first. All right, the first thing I'm going to recommend is see if you can simplify this to be in terms of just sines and cosines. So we know that cotangent is cosine over sine, and so then we're going to simplify to see what we have here. Okay, so this is not a product of sine and cosines, but this does involve a cosine to an odd power, And you notice because you have sine in the denominator, that's giving you a natural substitution to go with. We're going to want to let u be sine because that's in the denominator, which means we're going to want to pull out a cosine for our du. And then we're going to want to rewrite this term right here to be all in terms of sine because that's what we're going to do for our substitution. So we know cosine to the fourth is the same as 1 minus sine squared all squared. And then you're still left with the cosine that you pulled out. And this whole thing is over sine of x dx. So now we're ready to do our u sub. And then again, now you're just going to expand this out, simplify terms, and then integrate term by term. The easiest thing to do at this point is just to break this up. Okay, and now you're ready to, now you're ready to integrate term by term. Let me get some room here. And then lastly, you'll put this back in terms of x. And that's it.